Hi all of you. Welcome to another lecture of antenna and wave propagation. That is the effect of Earth's magnetic field. And one more topic, ionospheric abnormalities and absorption. Myself Maria Joseph, Assistant Professor in Electronics and Communication Engineering Department of MBC CT Pyramid, leading the session. Effect of Earth's magnetic field. The Earth's magnetic field splits the incident radio waves into mainly two components. One is the ordinary waves and the other one is the extraordinary waves. Okay, a radio wave propagating in atmosphere which is not ionized is not affected by the Earth's magnetic field. If it is ionized, it will be definitely affected by the Earth's magnetic field. The properties of ordinary wave is same as that of the waves without superimposed magnetic field. The extraordinary wave is distinguishable from the ordinary wave only in its upper region of F layer. These two waves have elliptical polarization and rotate in the opposite directions. The phenomenon of splitting of the wave into two different components of Earth's magnetic field is called magneto-ionic splitting. It is two components. The effect of Earth's magnetic field. Besides the splitting of incident wave, Earth's magnetic field is also affecting the polarization of the incident radio waves. The electrons in simple harmonic motion is now modified into elliptical or spiral motion by Earth's magnetic field. We know that if the frequency f is greater than fg, then where fg is the critical frequency, then it has got one type of polarization, that is the elliptical one, or you have spiral one if it is less than fg and critical frequency. What happens? This is the effect. Now the different types of ionospheric abnormalities. The first one is a sudden ionospheric disturbance, or SID. We call it as SID. Okay. Then ionospheric storms are there, sunspot cycle, tides and winds in ionosphere, fadings, whistlers, ionospheric cross modulations. So many ionospheric abnormalities are present in the ionosphere. We'll discuss each one in detail. Sudden ionospheric disturbances, or we call it as SID. The phenomenon of complete blackout is known as sudden ionospheric disturbances. It may be noted that during the sudden ionospheric disturbances, the very low frequency propagation actually improves. SID is caused due to the radiation of intense UV light from solar flares, which penetrates upper ionosphere and cause very strong increase in ionization in the region. We know there are different layers of the atmosphere. Second one is the ionospheric storms. They are nothing but the disturbances in ionosphere which are correlated with rapid and exclusive fluctuations associated with magnetic storms. The effect of ionospheric storm on the short wave radio transmission is to narrow the range of frequencies. Now, the tides and winds in the ionosphere. That is, atmosphere also experience some tidal pulls from actually the sun or the moon, because just like it happens in the case of oceans. However, in case of atmosphere or ionosphere, the solar tidal effects get more amplified. It is because of the resonance actually present. Now, the winds in the ionosphere is mainly caused by the tides. Although at times some other effect may be responsible for it, we know that all this will affect the ionospheric propagation. The next is the sunspot cycle. Actually, the sun has a 11-year cycle over which its output varies tremendously. So there is variations, and this also can affect the ionospheric propagation. The next one is the ionospheric cross modulation, or you can say it as Luxembourg effect. That is Luxembourg effect or ionospheric cross modulation. While listening to a very distant medium frequency broadcasting station, sometimes it is seen that there is a continuous background of some more powerful station, usually of lower frequency. This effect is observed. R by T stations first began to use very high power. For example, a radio is tuned to a radio station, received the background of radio station from another station. Since this phenomenon was first observed by the listeners involving Radio Luxembourg, and hence it was termed as Luxembourg effect. Or you can say, if there is the interference of some signals from different stations into our propagation, then we call it as ionospheric cross modulation, or that is actually the principle behind the ionospheric cross modulations. Then as you know, it also has got some man-made noises which will also affect the ionospheric propagations. Fadings. Fading is actually a fluctuation in the received signal strength at the receiver on a random variation in the received signal is known as fading. There are different types of fading. The first type of fading is the selective fading. What do you mean by selective fading? That is, it produces serious distortion of the modulated signal. Since fading is frequency selective, it is just possible for adjacent portion of signal to fade independently, although their frequency separation is only a few dozen hertz. Then that is selective fading. Then you have the interference fading. That is, it is most serious type of fading, and it is produced by the interference between the upper and lower rays of a sky wave. Then the third one is absorption fading. This occurs due to variations of signal strength with a different amount of absorption. Then the other type of fading is the skip fading. This is which occurs near the skip distance. We will see what skip distance is. Polarization fading is there. Fading occurs due to the change of polarization of the downcoming sky waves. All this will depend on the polarization fading. Now another type of ionospheric abnormality is whistlers. Okay, what do you mean by whistlers actually? It has now been determined that the atmospheric whistlers are associated with the electromagnetic pulse of audio frequency radiation propagation along lines of Earth's magnetic field between the conjugate points of northern hemisphere and southern hemisphere. That is, the atmospheric whistlers are actually associated with the electromagnetic pulses of audio frequency radiation propagation along the lines of the Earth's magnetic field. And where are their conjugate points? Conjugate points are in the northern hemisphere and in the southern hemisphere. Thank you so much for your patient listening.